Alright guys, we're going to start. We're not going to be proving again for just a little bit. We might have some proofs thrown in here and there, but we're not actually going to be doing proofs for a little bit, okay? Go ahead and open your notebook though to page 58. Yeah, 58 is where we're going to be starting. We are doing some more triangles. All this stuff is triangles for a while. But 58 is 7.1, interior and exterior angles. And that's the title for 58 and 59. Go ahead and do that. There are notes attached to this video because it's not in your book. It is a foldable. Which, of course, if you don't have a printer, you can just take a piece of paper and fold it in half and make your own foldable. That's fine. Okay, so I'm going to put this to the side because I'm going to work on a foldable. So, your foldable, we're talking about 3 theorems today. One of them you actually already know, I promise. The other two, pretty sure you don't, but that's okay because we're going to learn them now. So, you've got this piece of paper, you're folding it in half, it's got 3 theorems. You need to familiarize yourself with these 3 theorems because on a quiz this Friday, it will ask you which theorem you've used to solve the question. So just a warning, you need to know the theorems. All right, the first one I'm pretty sure you know is the Triangle Sum Theorem. So we're going to open it up and talk about it. The Triangle Sum Theorem says the sum of the angle measures of a triangle is 180 degrees. So we labeled these. Let's label this angle 1, angle 2, and angle 3. The theorem says that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. That's the one I'm pretty sure you already knew. We've used it before. You learned it before now. But if you don't know it, you sure need to know it now. All right, the Polygon Sum Theorem. The Polygon Sum Theorem says the sum of the measures of interior angles on a convex polygon. This is a convex polygon. There's a concave polygon as well, and a concave polygon would look something like this. It goes inwards. It doesn't work for that one. The sum of the measures of the interior angles on a convex polygon with n sides is n minus 2 times 180. We're going to do an example of that here. Here we have a hexagon. The hexagon has 1, 2, 3, 4, 5, 6 sides. So we are going to use n minus 2 times 180 to find how many or what this adds up to on the inside. So 6 minus 2 times 180 is 4 times 180, which is 720. That means that these 6 angles add up to 720. Now listen, that does not mean I can do 720 divided by 6 to find these. I can only do that if it says it is a regular hexagon. Just like in a triangle, I can't say, well, all of these are 60 because 180 divided by 3 is 60, unless it says it's equilateral, okay? That just tells you what they all add up to give you, okay? Exterior angles theorem. In the exterior angles theorem, it says the measure of an exterior angle of a triangle is equal to the sum of the remote interior angles. We need to talk about what a exterior angle is and what a remote interior angle is. Then we'll get the theorem itself. So we're going to skip down here kind of the bottom. We're going to label them 1, 2, 3, and 4. Angle 1, angle 2, and angle 3 are remote interior. They are remote interior angles because they are not connected to the exterior angle, which is on the outside. Angle 4 is an exterior angle. Now all 1, 2, and 3 are interior, but 2 and 3 are remote interior. Okay. So this theorem over here then says the measure of angle 4, the exterior, is equal to the sum of the remote interior, which is 2 and 3. So the sum of these is equal to this. And that's true because this is a straight line, right? This 4 plus 1 is 180 degrees. Well, 1, 2, and 3 is 180 degrees, which means that would give you the proof to show that this is actually true here. We're not going to do the proof, but that's where the proof comes from. All right, we are going to use these 3 theorems to do the problems that we're going to work on today. So we're going to go ahead and glue this in on page 58. And then we'll get the other handout going. Okay, so we've got another handout. You'll go on 59, but we're going to work it first, obviously. You'll need your other one still out because we're going to have to use it. All right, some examples. Determine the unknown angle measures. Number 1, determine the unknown measures of a convex octagon in which the measures of the 7 other angles have a sum of 940 degrees. For all of these, the first thing that you are going to have to do is find out what the total sum of angles is in the shape or figure they give us. So we're working with an octagon. That means n equals 8. So 8 minus 2 times 180. 8 minus 2 is 6 times 180. That means that there are 1,080 degrees total in an octagon. That's the first part. You always have to find how many total degrees there are before we can do anything else. Now let's read the rest of the question. So we want to know the unknown measure. The measure of the 7 other angles add up to 940. So we already have the 7 other angles, and they add up to 940. So we need to see what's left over for the 8th angle. So we're going to do 1,080 minus 940. It's going to give us 140 degrees. So the answer is 140 degrees is what's left for the other angle. Number 2. Number 2, determine the unknown angle measures in this pentagon. Pentagon has 5 sides. 5 minus 2 times 180. That's 3 times 180. That is 540 degrees in a pentagon. All right, we are trying to find the measure of x. We have 90, 90, 90, and x and x. So we have all 5 of them. There's one of them. Here's another one. Here's another one. Here's another one. Here's another one. Just like if we're doing something for a triangle, we add all the angles and they equal what the total should be. So we have 2 x's and we have 90 plus 90 plus 90, and that equals 540. We subtract 270 and we get 2x equals 270. We divide by 2. X equals 135. So our missing angle measure is 135 degrees. Sometimes we'll have to go back and plug in. You're going to see that in number 3. We will not actually do an exterior angles theorem example. It will be in your notes, in your homework, which means if you need help on that, you need to ask. I'll try to remember to open the Google Meet in case you need help with anything. If I don't, and I forget to open the Google Meet, send me an email. I'll open one if you need help on the exterior angles homework. Number 3, determine the unknown measure in a hexagon. A hexagon is n equals 6. I will tell you, after a while, if I've already found and done the math for this, I don't want to keep doing it. So let's look. We already found how many degrees are in a hexagon, so I'm not going to do the work. In a hexagon, there are 720 degrees. If you have already found it, you don't have to do it again. If you don't remember it, you will have to do it again. All right, here are the 6 angles. We are going to add them up and set them equal to 720. So we got 69, 108, 135, 204, B, and 2B, or not to be. Terrible joke. Okay, it says determine the unknown measures. We don't know B and we don't know 2B, so those are the ones we're going to have to find. So we need to add up all of our like terms. B plus 2B is 3B. All right, and then 69 plus 108 plus 135 plus 204 is 516. Subtract 516. 3B equals 204. I better check that. Yes. Divide by 3. B equals 68. Okay, this says find the unknown angle measures. One of the unknown angle measures is 68 degrees. The other one is 2 times 68 degrees, and that's 136. There are 2 missing angle measures. You can't see that, sorry. Okay, so like I said, the interior or the exterior angles theorem, I don't have an example of that here, but if you need help on it, let me know. I'll help you out. It's in your homework. So go ahead and start the homework. We're going to glue this in first and then start it, but this goes on page 59, and then you can start whatever it asks you to do on Google Classroom. All right, there we go, and I will see you for tomorrow's lesson.